Enough buzzwords in one title. I really want to thank everybody for coming out on a night when it's so cold out and you have to get home in the cold and get here in the cold, and also that you came to see me and Nathan instead of Justin Timberlake, which is really flattering. Thanks for that. And big shoes to fill. Yeah, next door. That's why it's so busy out. Yeah. All right, so what I'm going to talk about, I'll start at the very beginning. What is isomorphism? We'll talk about what isomorphism is specifically with regards to JavaScript and building web-based applications. Why or why not you might want to think about building an isomorphic application for your next project. And finally, I'll just show a really, really simple working example which kind of puts everything together and illustrates how you would go about setting it up. So first of all, what is isomorphism? Literally, I think in Greek it means the same shape. If you look up isomorphism in your favorite search engine, the first hits you get are all about crystallography, I think. So it can mean different shapes of different things. But in programming, it typically means functions that accept the same input and return the same output. So not worrying about the underlying implementation of how you get from A to B to C, but just that if you give it this input, you'll get this output back. So the external shape is the same regardless of what's inside of it. And in the JavaScript world, this is a really important concept because JavaScript is a language. It's not really an execution environment or a single runtime. And so code that works the same way in different environments, usually Node.js in the browser, can expose the same types of things to the user of a library, but not, of necessity, not implement that thing the same way. So a simple example of this, I'm sure it's not simple for the people who developed it, but simple in the context of an app, is the Axios library, which makes HTTP requests. So for example, this is an isomorphic library. If you write code like this, regardless of whether it executes in Node or executes in the browser, it will fetch something from that endpoint, and then it returns a promise, and you can do something with the response. But how that is implemented under the hood is different depending on where the library is running. And so that's really useful for the consumer of the library because you can use things the same way without even knowing necessarily where your module is going to be used in the future. But things get a lot more complicated when we're talking about the UI level, when we're talking about rendering things for the user to see. And the reason for that is that on the client, we're thinking about building a DOM and all of the things that are attached to the DOM, whereas on the server, what we really have to do with a library like React or similar is just render an HTML string. So the way I typically think about building an isomorphic application or how you would serve these types of requests to users from beginning to end. As always, the client's machine is going to make a request to the server. The server will process that request, figure out what the state of the application is, depending on the URL and all of the other things that come along with the request, render some HTML, return that HTML, as well as something called state, as well as the actual state, which is something that I'll get back to in a minute, back to the client, which will then display this sort of static version of the HTML to the user immediately, even though there's no JavaScript and it's not functional in any way yet. Once the browser is rendering the page, it will find all the script tags and all of the resource tags, request those scripts from the server. The server serves the scripts back. The browser can then parse and execute the script. And then what happens is that a smart library like React can take the script and hydrate the state of the application from both the state and the code that's in the script. And so what you end up with is even though you've gotten to the DOM via two different paths, you hopefully have the same representation of the DOM in both cases. It's just you've gone from having a static HTML version of the DOM to a live version of the DOM that the user can interact with. So maybe I wasn't quite clear. I'll get a little more into why, or a little more into how this would work a little bit later. But first of all, why would you want to go through this whole process and do all of this? Firstly, there can be performance benefits, not so much the actual performance, because you still need to load a script and get it running before the user can actually do anything, but the perceived performance of your application can be higher with this sort of setup. So what I mean by that is just before this talk, I was ordering those pizzas from Panago, and when you first load Panago's interactive pizza ordering app or whatever it is, when you load the page, you just see the footer for like a really long time before the app loads and pushes it down to the bottom of the page where it's supposed to be, and you get you finally see the things that you're actually interested in. I'm sure everybody who's used the web has had that experience. So with this kind of setup, because you're serving a static version of the page before it becomes live, the user actually sees the entire page before they're able to interact with it and before the script is fully downloaded. And they can, begin thinking in their minds about what they're going to do, even if they're not able to actually click on it and do anything with it yet. There may or may not be SEO benefits to this sort of setup. If you think about a web crawler visiting all of these different sites, Google claims that they do, or I'm sure that it's true, they do execute the JavaScript that you serve to the search engine, and so they are getting an accurate representation of the initial state of each page, as long as you're not making too many external requests and need a lot of data to render that. So you can check if Google is accurately representing your page in their search console. And of course, there are other search engines than Google, so you might want to think about those as well. I think that the sort of broader picture is the question of inclusivity or reaching a wider audience. And what I mean by that is that once JavaScript code leaves your server, you don't really have any control over what the user agent does with it. Both the browser as well as other user agents like search engines, gaming consoles, Opera Minis, proxy browsers, and all of those types of things. And so even though in this day and age people don't usually turn JavaScript off, there could be errors in code that you don't really have any control over that are causing crashes in the application as it's running in the browser. And if they're able to see a version of the page that's rendering on your server where you have control of it, then at least they're still getting a part of the user experience. So it's a kind of progressive enhancement. And of course, HTML and CSS, you don't control what the browser does with that either, but as declarative languages, they're a little bit more robust and error tolerant. Yeah, just skip that. So why would you not want to do this? First off, your server, at least part of it, has to be using Node.js. You need a JavaScript execution environment to execute JavaScript. It definitely increases the amount of time that it takes to build things. I actually got the idea for this talk while I was, the idea for this talk came from our year-end JavaScript survey, and at the time I was working on an application that utilized server-side rendering pretty heavily with Vue.js. And it takes longer to build things this way because you're working through multiple different paths to get to the same end state. And so the feedback loop of testing things and changing things can get really slow. It's important to have a good testing system set up really before you start with this kind of thing. So I'm just going to show a really simple working example and then a little bit of the code. I'm not going to take too long, but this is available at this address. It's a simple, just single React component website that is just a validator for an email address. So if I start typing, it's telling me this is an invalid email, and if I eventually get to the state where it is valid. So it's using live JavaScript, actually written in React, to give me an interactive experience. But if I turn JavaScript off, and this is surprisingly hard to do in Firefox, and reload the page, so I don't get any of the interactivity now. But I can still submit it just like an old school HTML form, and it will validate or not validate my email address back. So I'm just going to go through a little bit of the code. I'm not going to sort of reintroduce React and what it does, because I think most people are pretty familiar with that at this point. This is just a simple React component. But one thing I've been careful about here is to just use regular HTML tags as well. So this, inside of here, this is an input field. This is also just a form element, and just like a form element that you would build in a primarily server application, it has a method and action attribute to go along with it. As you would probably expect, there's a change handler so that when the user makes a change in that email field, it updates the state of this component. And then the one thing that's a little bit different is that we're setting the initial state of this component to a prop. And the reason for that is so that we can kind of dictate our starting point based on the state of the application when it first loads. So what do I mean by that? Well, on this page, what my server is doing is determining what the state of the application should be at any given point, and it's putting it in this JSON encoded object and just assigning it to window.state. And that is so that my client-side code can grab it, so this file executes only on the client, and it just grabs the state out of that window property and assigns it to the initial state of the application. So that's passed down as a prop, which then becomes the state of that top-level component. And React DOM rather, actually introduced this method hydrate, which you're now supposed to use instead of a prop when you're doing this. And I love that word because it's such a clear description of what's going on here, that we're taking an existing DOM in the browser and making it functional, like filling it with water or something like that. So the other sort of side of this is the entry server file, which is what's getting called by Express. And it's passing in an object representation of the initial request, and we're just sort of constructing the state on the fly as a result of that. And then passing back one other step here is we can use React DOM's method render to string, which is different from render because it's just creating an HTML string out of a React component. And then we're passing that back to the Express server, which is just inserting that string into the HTML, which is going to send back to the browser as well as the state. You'll also notice that I'm returning a promise here, and that's completely unnecessary the way it's currently working, because we're just taking the email from the user and basically sending it back to them. But in the real world, typically this makes database calls and has to do all kinds of work to figure out what the initial state of the application is. So I find it easier to just think about the server as receiving a promise rather than receiving a synchronous action. I think that's really all I wanted to say about this. The code is up on GitHub. The only other thing is you do have to run your server-side files through Babel because this uses JSX with React components. But other than that, happy to just stop here and take any questions if there was anything I sort of glossed over. So Mark's asking, what's the primary use case? Is it more performance or is it more SEO? Mm-hmm. I think both of them can be advantageous. I don't think it's a good fit for every kind of project, but I think there are projects where it would be a huge benefit. So if you think about, like, say you were building a blog system or something like that where the content creator doesn't have to type their blog post out in like this completely different looking text box to create a new blog post. Well, then for 99% of the users of that blog, they're just regular website visitors, and for them it's just a regular website and the interactivity is not really important. But for that, for those content creators, it's they need the interactive part of it. So I think that there would be a benefit for that kind of application. We were using it on a real estate search tool where the SEO benefits were really important. We basically wanted to make Google's life as easy as possible, but because it was like the type of search tool where there's all kinds of different fields and the user is constantly able to filter things in different ways and sort things in different ways, then a high amount of interactivity was important that you wouldn't get with like a regular server-based submit a form and get HTML back type of setup either. Okay. So. All right.